In this lesson, we continue with trigonometry. This is lesson 8 and we'll start general solutions. Now, when solving general solutions, it is important that you follow these steps. So step 1 of a general solution is that you'll be given whatever you are given, and the aim is to take that information and turn it into one trig ratio equal to a number, or aim to have it factorized. So you want to have it factorized, or you want to have one trig ratio equal to a number. For example, we have over here sine theta plus 30 degrees, that is one trig ratio, is equal to negative a half. It is equal to a number. So that's the first thing that you want. If you can't do that, then you need to factorize. So we want to have it factorized. For example, we have cos theta plus 2 and another bracket 2 cos theta minus 1 equal to 0. So that's the first step. You want to have it like this. Step 2, you need to find the applicable quadrants. Say now we have sine theta plus 30 degrees equal to a half. Now it's time for you to find the applicable quadrants where you'll be calculating the general solutions of. So because it is sine and it is equal to a negative a half, sine equal to a negative a half, we'll say that we know that sine is negative in, you follow the cos diagram, okay? We'll say that sine is negative in quadrant 3 as well as quadrant 4. So those are the quadrants that you'll be working with to find your general solution. Now step 3, it is for you to find the reference angle. So now again, having sine and we have theta plus 30 degrees equal to negative a half. Now we'll say that the reference angle here, so the reference angle is going to be inverse sine. So you take that trig ratio and you take the inverse of it and you take that number it's equal to. But make sure that when you substitute that number, it must always be a positive. You only substitute positive values when finding the reference angle. So now we substitute that into the calculator and you probably get something like 30 degrees. Now step 4 is for you to find the general solutions using the applicable quadrants. Now when it's time to find the general solution, you need to remember your reduction angles. If it's in the first quadrant, we say that it's theta. If it's in the second quadrant, we have 180 degrees minus theta. In the third quadrant, 180 degrees plus theta. In the fourth quadrant, 360 degrees minus theta. So that's what you want to remember. So now we know that our applicable quadrant is quadrant 3. So we are going to work with the third quadrant and we are going to find the general solution in the third quadrant. Now to find the general solution, you must take the angle that you had. So the angle we had here was theta plus 30 degrees. So it's that angle. It is equal to, now in the third quadrant we'll have that it's 180 degrees. Okay, so in the third quadrant our reduction angles look like 180 degrees plus theta. Now we're going to say 180 degrees plus the reference angle. The reference angle in this case we calculated to be 30 degrees. Now because it is sine, we are working with the trig ratio sine. We need to add 360 degrees times k to give it that general formula. So then now we need to simplify for this. So we're going to take this positive 30 to the other side. And now theta is going to be 180 degrees. The 30 and the 30 are going to cancel. Plus 360 degrees times k. And we have to mention where k is an element of integers. And that's how you find your general solution. Now this was for the third quadrant. We have to now calculate for the fourth quadrant. So quadrant 4. Okay, so for quadrant 4, we'll say that that angle of ours, which is theta plus 30 degrees in this case, it is equal to, now we remember our reduction angles look like 360 degrees minus theta. In this instance, we're going to minus the reference angle. So we're going to have 30 degrees, and then we need to include the 360 degrees times k because we want a general solution. Now you're going to take this 30 degrees to the other side. So we're going to have theta is equal to 300 degrees plus 360 degrees times k. So these are your two general solutions, and you must include that where k is the elements of integers. Now remember, whenever you are using cos or sine, you always say 360 degrees times k, and whenever using tan, you're going to have 180 degrees times k. Now step 5 is you will have to then find the applicable values of theta. In this instance, we want the applicable values of theta where theta is trapped between negative 360 degrees and 360 degrees. Now to find this, we'll have to substitute values or integers in the place of k to be able to find the values of theta. So now let's just remember, we had our general solution was theta equal to 180 degrees plus 360 degrees times k, and we'll start substituting these values into k in the place of k and be getting these values of theta. The other general solution was theta equal to 300 degrees plus 360 degrees times k. So now let's start substituting. So now in the calculator, I'll type in 180 degrees and I'm going to add 360 degrees in brackets. I'm going to put, firstly, let's start with minus 3. And let's see what minus 3 gives us. Minus 3 gives us negative 100. Negative 100 is out of the range of negative 360 degrees. It's just outside the range, so we can't use that. Now let's go ahead and try to calculate if you put negative 2. Negative 2 also is outside the range, so we can't use this. And then we use negative 1. Negative 1 gives us negative 180. Values of theta we are going to get is going to be negative 180 degrees. And we're still going to continue solving for this. So now if you type in or substitute 0, so if you substitute 0, we find that it's positive 180. So we write here positive 180. And we keep on searching until we get the ones that are out of range. So if you substitute a 1, we get 540 degrees, and that is out of range. So the only two values we get from this formula is negative 180 and positive 180 degrees. Now we are going to do the same thing for this formula over here. So for this formula, we need to retype 300 plus 360 degrees, and then in brackets we're going to substitute firstly minus 2, and let's see, minus 2 gives us negative 420, which is out of range. It's just too negative, so we can't take this one. And then we can substitute and we get negative 60. So negative 60 is within range, so we put that one down. So when you substitute 0, we get 300. So 300 is also within range, so we put that in. And then we know that now if you substitute 1, we are going to get a value bigger than 360 degrees, and that means that these are the only values we have for our theta. So then we just give them and say that theta is equal to, and then you like to put them in increasing order. So we put negative 180 degrees, and then we put negative 60 degrees, and then we put positive 180 degrees and positive 300 degrees. And these are our values of theta. So now in this next example, we are going to obviously practice how to find a general solution using the steps that we discussed previously, although I am not going to do step 5 with you guys here. Now finding the general solution here, I'm going to have to say, therefore, I have two terms, And when I have two terms and they both have a sign, I can just factorize. So I'm going to factor out a sine x. Then I have 1 minus 2 sine x equal to 0. So then when we have this, we'll say that sine x is equal to 0, or we are going to have 1 minus 2 sine x is equal to 0. Therefore, this side, we want to get the sine x as the subject of the formula. So we're going to have 1 over 2 as the answer here. So sine x is equal to 1 over 2. Alright, so now that we have a trig ratio equal to a number, the first thing you want to do is cast diagram. Say sine is equal to a positive number, so that means that we are working with the first and the second quadrants. And the next thing you want to get is the reference angle. So we say the reference angle is inverse sine, and remember to always substitute positive values here. You want to always substitute positive values there. So now into the calculator, we are going to substitute inverse sine, and a half is just 0.5. So we know it's going to be 30 degrees. So we say that the reference angle is going to give us 30 degrees. Now, to find the general solutions, we'll work with the first quadrant. So I'll say first quadrant. We say that angle that we are talking about, which is x in this case. So x is equal to the reference angle. In the first quadrant, you just have theta. So x is equal to the reference angle, which is 30 degrees plus 360 degrees times k, to turn it into a general solution. In brackets, say k is an element of integers. Then we work with the second quadrant. In the second quadrant, what we'll find is that x, that angle we are talking about, is equal to 180 degrees minus theta. That would be the angle of reduction, but in this case we say minus the reference angle plus 360 degrees times k. Then we simplify this a bit more, so this is going to be 150 degrees plus 360 degrees times k, where k is an element of integers. So these are your two general solutions that we have according to this O. So according to this trig equation, whenever you have a trig ratio equal to 0, so we have this equation whereby we have sine x equal to 0, the general formula is always going to be the same. Now to get this, we use the mother graph. Okay, so we say that normally the mother graph of sine x, when you draw the graph sine x, it's going to look something like this, whereby it is 0 here at 0 degrees, and it's 0 there at 180 degrees, and it's also 0 there at 360 degrees. So then the general solution for this will say that x is equal to 0 degrees, okay? Because you're asking yourself, where is sine x 0? It is 0 at 0 degrees, and you just add 360 degrees times k. And where else? It's 0 at 180 degrees, so we say 180 degrees plus 360 degrees times k. Now there's no need to say now 360 degrees again plus 360 degrees times k, because the first one already took into account for the last one. So whenever you have sine x equal to 0, these are going to be your general solutions always. Now for trig ratios equal to 0, we need to use the mother graph. Now let me just show you how your general solutions will be for cos x and tan x. So cos x will say, okay, well, the graph of cos x is going to look something like this, whereby we know that it's 0 at 90 degrees and it's 0 at 270 degrees. Now because of that, the general solution is going to be x equal to 90 degrees plus 360 degrees times k, where k is the elements of integers. You must always put this. And then we also say x is equal to 270 degrees plus 360 degrees, where k is an element of integers. Now let's go over to 10x. So 10x, we know that this graph of 10x is going to look something like this, whereby we have asymptote at 90 degrees and we have asymptote at 270 degrees. And then the graph of 10 is going to look like this. And the graph of 10 is going to look like this. All right. So this is what we have for the graph of 10. So we know that it's 0 at 0 degrees, and 0 again at 180 degrees, and it will be 0 again at 360 degrees. So here with 10, the only thing you want to do is you'll say that x, that angle. So remember, you're always taking that angle. If it was x plus 30 degrees, you'll say x plus 30 degrees is going to be equal to 0 degrees plus 180 degrees times k, where k is the element of integers. Remember, for 10, we're using 180 degrees, not 360 degrees. And then we have also x is equal to 180 degrees plus 180 degrees times k, where k is the element of integers. Now we know that these two are actually the same. They're actually the same formula. They'll always give you the same answers, but just write both of them to be on the safer side.